Hello everyone. Today's topic is measurement of RLC unit, which comes under the electrical and measurement and instrumentations for engineering students. And in this unit, we will study how we measure the resistance, capacitance, and inductance of a unit. Okay. So now let's move on the classification of resistance. There are three main types of classification of resistances, that is the low resistance. The resistance with value below 1 ohm is called the low resistance. Then for medium resistances, 1 ohm and upwards to about 1 lakh ohm or 100 kilo ohm comes under the medium resistance category. Then for high resistance, 100 kilo ohm and upwards comes under this category. Okay, so there are different methods for the measurement of resistance. Today we will see how we measure the how we measure the resistance of medium resistances. There are four methods that are available for the measurement of medium resistances, that is ammeter voltmeter method, substitution method, Weston bridge method, and ohm meter method. First, we will see what is ammeter voltmeter method. Okay, so first, this method is used for the measurement of medium resistance. Medium resistance means above 1 ohm and up to 100 kilo ohm comes under this category. Okay, for ammeter voltmeter method, we used one ammeter. These are the two uh, cases that are possible in the ammeter voltmeter method. We use ammeter and voltmeter. This method is very popular because the instruments that we use for this method are easily available to us. That means ammeter and voltmeter are easily available in laboratory. That's why this method we use for the measurement of resistance. Okay, so here this ammeter voltmeter method works on the principle of Ohm's law, that is resistance is equals to V by I. First we see the first method, that is first figure. Okay, this is our first figure. Okay, now for this figure, this ammeter has some internal resistance, that is RA, and this voltmeter that is connected here also having some internal resistance. It is denoted by Rm. Okay, then for this method, this V, we calculate the voltage as sum of this voltage of ammeter plus sum of voltage of this resistances. So we got the voltage which is the sum of this ammeter voltage and unknown resistance R voltage. But current in the unknown resistance is nothing but the current that is comes from here, that is the resistance R. So this is the important point we keep in mind, that for voltmeter, the voltmeter here now denotes the sum of voltage across the ammeter and sum of voltage across the resistance, but the current in the unknown resistance is same, that is current I is equals to R. Now this voltage drop across this ammeter, that is V, is nothing but a current and resistance across this ammeter, that is internal resistance IA. Now the voltage drop across the resistance is nothing but the current I into this unknown resistance R. Now if we measure the value of resistance, that is this is denoted by Rm, then Rm1, that means the measured value of resistance. By Ohm's law, resistance is equal to V by I. But in this case, the voltage is with the sum of VR plus VA that we calculate here, and the current is nothing but I. Okay, now we substitute the value of VR and VA. We get this measured resistance is the sum of unknown resistance plus resistance, some internal resistance across the ammeter. When we calculate the true value of resistance, that is unknown resistance R, we get Rm1 minus Re. Now we substitute. Now we make the Rm1 um, common. Then we get this formula. Okay. From this, we can say that when this unknown resistance is equals to the measured resistance, when this RA is 0, that means this factor is 0, then only the unknown resistance R is equals to the measured resistance. For this, that means we can say that for getting the true value here, we make the internal resistance of ammeter is 0. But this is not a practically possible because ammeter has some internal resistance always. Its internal resistance should not be 0. Okay, so that means this gives some kind of error. This error is nothing but a difference between the measured value and true value. And that is how we calculate the error, that is difference between the measured value generated by Rm1 minus true value generated by R. Now when we find the relative error, it is nothing but the absolute error divided by true error, true value, sorry. Now this is called the absolute error. So when we put here, we got the relative error is equals to RA divided by R. This error is small when this RA is small and R is high. Okay. So we can say that this method is used for the measurement of high resistance. Now, next case, that is this kind of for this kind of a connection. Similarly, this ammeter has some internal resistance RA, voltmeter has some internal resistance. For this voltmeter has some internal resistance. Let RV be the resistance of a voltmeter and current through the voltmeter is IV. For this case, the voltmeter reads only the voltage across this resistance. That means here the voltage through this voltmeter is nothing but a voltage across this unknown resistance. Therefore, here the voltage is equals to the supplied voltage is equals to the sorry. Okay. Uh, for this case, the voltage is same, but the current here is divided. That is, IV is the current passing through the voltmeter, and I is the current passing through the unknown resistance. That means here the current is the sum of IR plus IV. Okay. When we measure the unknown resistance, which is denoted by R into by Ohm's law, it is V divided by I. Therefore, V divided by here I is the what summation of two currents. Therefore, we got this formula. Now, when we calculate the true value of resistance, we get the okay. When we calculate the true value of resistance, then we get okay. From this equation, Rm2 is equals to R divided by 1 plus R by Rm. We get true value of resistances like this. This unknown resistance is equals to the measured resistance. When we make this value, that is Rv, that is resistance of voltmeter is infinite. But this is not possible because uh, the resistance of voltmeter is never infinite. That's why it gives some kind of error, which is given by R into by R into minus R, and relative error we got is minus R divided by RB. So this error is small when this unknown resistor is small as compared to the RB. Hence we can say that this is we use this method for the measurement of low resistance. Thank you.